Relax key in your attendance. Okay, so another 1 minute. 25. Class will be continuing with the thermodynamic. Just the last part for today. Today is the last part for thermodynamic. Okay, we do questions. We try to strengthen the idea of thermodynamic. Okay. Okay, so as we go back to what we did last class. Okay. So I go to the Word file. Right. Okay, so recall back what is internal energy. What is internal energy? Okay. So the sum of kinetic and potential energy possessed by all the particles in the substance due to random motion. Okay. So kinetic energy proportional to what? Thermodynamic temperature. Temperature rise, kinetic energy rises. We know that well. Potential energy looks like inversely proportional to the intermolecular force. Intermolecular force get weaker, potential energy rises. Okay. So the highest potential energy attained by which substance? Ideal gas. Okay. How much? 0. Okay. Then first law of thermodynamics, recall back. Okay, try to grab by heart what is meant by first law of thermodynamics. What is first law of thermodynamics? It's based on conservation of energy. Yeah, that is the first law, right? The first law of thermodynamics states that the change in internal energy of a substance is equals to the heat supplied to the system and work done on the system. Okay, work done on the system. Okay, remember. So changes of U, Q plus W. Okay, Q, W. Yeah, W is what? Please include how to find W. Integration of P dV. Pressure, the pressure versus volume, the area in the graph is the work done. Okay. Okay. Then we talked about, of course, the fill up the plus minus 0, which is plus minus, which is 0, based on first law of thermodynamics. And I told you when what becomes 0. When work becomes 0, work becomes 0 when what 0? When changes in volume become 0. No change in volume, no work done. Okay. When Q becomes 0, when heat supplied becomes 0, when they say it's a free expansion of compression. Okay. When changes of U become 0, changes of U become 0 when there is no changes in the temperature. Only for idle gas. Only for idle gas. Only for idle gas, change in temperature is 0 means no change in internal energy. Okay. If solid to liquid, check potential energy involved, so internal energy might rise. Okay. And what need to be added? Yeah, solid to liquid, when change, work done is 0. Solid to liquid, when phase change, work done is 0. No significant change in the volume. Okay. Okay, the last part for today is that we read about this graph, right? This graph. The gas can go from the initial to final position P to R. Okay, when the point are more to the right and top, like in this case the R, the PV value is very high, so the temperature going to be very high. So PV equals to nRT, right? So PV high means T going to be high. So that means you should know in the PV graph, the point which is further to the right and to the top, that point, the gas possesses the greatest internal energy. Okay, why? Indirectly, you should know it. That's the point where it possesses the highest temperature. Okay, so PQRS, R has the greatest internal energy. P has the lowest internal energy. Okay, Q and S may be same temperature because Q is P high, V small, S is P small, V high, so the product might be the same, so temperature might be same. But definitely R has the greatest temperature. This is a shortcut you have to predict. So if P goes to R with any path, PQQR or PSSR, what same? The changes of U is same. Okay, change in internal energy will be the same, and P to R, the same initial final point, but they take a different route. The changes of U will be the same. Okay. Okay, so yeah, the last one. Okay, now with numbers. Again, P versus V graph. Okay. So A, B, C, D is a 4 position. Of course, the D has the greatest internal energy, high temperature. Okay, now question. Need to fill up this value. Okay. Let's try. You have to use the first law of thermodynamics to fill up this value. Okay. Earlier we fill up plus minus 0. Okay. Now you have to fill with numbers. Okay. Okay. Now look at this question. An ideal gas undergoes a cycle of a change from A to B, then to C, and finally to D, as shown in the graph above. So look at here, it go A to B, B to C, C to D, and D to A. You come back to A again. Go one round. So yeah, the gas from A go to B, then C, then D, then A back. So finally come back to the same point, same location. So during the process, when you change from A to B, this is how the some energy change has been indicated. So A to B, the internal energy is found to be decreased by -50. Changes of U is -50. Okay, guys, please work out. Can you fill up all the numbers now? Use the first law of thermodynamics. Yesterday we put plus minus 0. Okay, now numbers. So go to the first law, changes of U equals to Q plus W. The law is applied for every transition. A to B, the law is applied. A to B, the changes of U must be equal to Q plus W. A to B. Okay, what you can fill up first? Which one you can fill up first? Always the work you can fill up first, right? Work you can get it from the graph. Okay, can you fill up how much is the work for this? A to B. A to B, how much is this first? A to B, how much the work done? Is it positive or negative? Okay, go back to the graph. So A go to B. What is the work done? The area under the graph of P versus V, right? That's the work done one. So what is work done from A to B? The area under the graph, right? The area under the graph. Under the graph. So in this case, this area, right? Okay. So find the value. So area under the graph is what? P changes the volume, right? So what is the pressure? Pressure is 100,000. Volume change how much? Yeah. So 100,000 multiplied by the volume change. Yeah, is 0.0002, right? It's minus. Get the joule, the work. No need to put negative, sorry. Just changes in volume. 100,000 times 0.0002. How much you get? 20. Get 20? 20 or 200? 20. You get 20. 20 joule. Okay, the work done from A to B is 20 joule. But be careful. Is it positive 20 or negative 20? It's compressed or expand? A to B. A to B, the gas has been compressed, right? The gas compressed, there is chance for the internal energy to go up. So give a positive effect to the internal energy. So the work is positive or negative? Compress. Compress, positive. Right? Compress is positive. Say it to be what? Compress, right? So, table. So of course this should be positive. This is positive 20 joule, right? Positive 20 joule. The work is positive 20. Okay, come on. I give you 2 minutes. Okay. Can you fill up all the numbers? After fill up this positive 20, what you can fill up? You can fill up the heat, right? What is the heat supplied to the gas? Use first law of thermodynamics. A to B. The internal energy was negative 50. Q we don't know. But heat was positive 20. So Q should be how much? Negative 70, right? Q should be negative 70 joule. So here should be negative 70. Negative 70, first law. Work is positive 20, internal energy reduced. That means heat must be negative 70. The gas need to be cooled down. The gas need to be freezed for this to happen. Gas need to be freezed so that compression happen. Right? Compression happen, internal energy goes down. So heat removed from the system was 70 joule. 70 joule of energy has been removed from the system. Cool. Okay, so we work together A and B, A to B. Can you get the answers for the B to C now? B to C will fill up the work and heat. Go to the graph. Find the work for B to C. B to C, go to the graph. So what's the graph? So B to C, the graph. So B, go to C, straight going up. So what is the work done? B to C. B to C, no change in volume. Volume doesn't change. So volume doesn't change means work done is 0, right? You never compress, you never expand, so no work done. So B to C, so for sure, the work is 0, right? No work done. B to C is, work done is 0. Work done is 0. Why? Reason? No changes in the volume. Yeah. So can you find the heat supplied? B to C. Use the first law. B to C also changes of U what? Changes of U equals to Q plus W. Okay. For any part of the graph, the law is applied. Okay. So B to C changes of U how much? It's positive 25. Q we are looking for. Work is found to be 0. So of course Q is positive 25. Heat also positive 25. This will be positive 25. Positive 25. Okay. Okay, now I give you 2 minutes. Come on. Try the others. C, D, D, A. Two minutes for you. I want the answers from you. Okay. C to D, D to A. Fill up the values. The first value you can fill up, of course, the work. Get the work values first. For both. Then you can get the others. You can discuss. You can discuss. Figure out what do you think the numbers should be. The tricky one is the last. Okay, the last. What do you call last column? The D2A. There is no value given. Not even one value given. But the gas come back to the same point. Gas come back to the same location. Come to A. From A, go to some round, come to A back. So what quantity going to become 0? What quantity going to become 0 when come back to the same location again? The changes in the internal energy going to be 0. The total change in the internal energy going to be 0. A to B internal energy decrease by -50. B to C internal energy rise by 25. C to D don't know, you can calculate. But these four add up. Okay, all the internal energy of these four add up. You should get how much? You should get 0. Internal energy rises for A to B, B to C decreases, rising, decreasing, rising. But when you come back to the same location again, the total internal energy, total up, rising, decreasing, all add up, should become 0. Okay, come back to the same temperature. Okay, so can you figure out all the numbers now? 2 minutes, come on. Fill up the work first. Okay. I think first you need to find the both work first. Get the both work. And yeah, after you get the work, I think you can fill up the internal energy. So what is the work for CD? Go back to the graph C to D. C to D, what is work done? The area on top here, right? Yeah. So CD is this area, right? And this is the work done. This is work done CD, right? Yeah, the entire area. So what is the area of work done? What? Height is 200,000, right? 200,000 multiplied by the differences again 0.002. Okay, yeah, how much you get? 0.0002. Sorry, 02. 4 zeros. You get how much? 40, right? Okay. So C to D, the work done is 40 joule plus 40 or minus 40. Compress or expand? The gas expand. Okay. Gas expand, work done is -40. Compress means positive, expand is negative. You have to remember by heart this. So here is negative 40. It's -40, right? Expand. Okay. So C to D, the gas expand, work done is -40. So can you find the internal energy here from C to D? C to D internal energy should be what? So Worth's law, Q plus W is your changes of U. So 140 minus 40. So this should be positive 100, right? Or C to D internal energy should rise by positive 100. Okay. Okay, now last one, D to A, nothing is there. Of course, work can be found first. But D to A work is what? D to A, no change in volume because no change in volume, D to A. So conclusion is D to A. The work is how much? 0. No work. No work is done by the gas. So work is 0. Okay, now we stuck. We don't know 2, but you should know because it came back to the same point. The negative 50 plus 25 plus 100 plus this x, which we don't know the x, must get 0. Okay. So that's the clue we have. So how much the x going to be? 125 minus 50. How much? Negative. The x is what? X is negative 75, right? Negative 75. Yeah, negative 75. So D to A, the x is negative 75. Okay. The internal energy decreases, negative 75. Okay. So then, can you get now heat supplied? How much heat supplied will be? Use the first law. Changes of U equals to Q plus W. So U is negative 75, W 0. So this should also must be negative 75. This is how the energy change. Okay. In exam, they will give an empty table. They ask you to fill up. Use first law of thermodynamics. Fill up all the numbers. Okay. The clue here, first thing you always can find out, always the work. Okay. Work you can find first. Okay. And remember, when you come to the same point, the total internal energy becomes 0. Okay. That's not say total. The change in internal energy becomes 0. Okay. The 4 changes add up must be 0. So you get the 4th number. Then you can look up the most of the time the heat will be the last to find. Okay. Okay, let's see how well you adapt this. Going to go another one question, another box, empty. I want you to get the answer. Yeah. Use the first law of thermodynamics, calculate the work. So for this is the last part of the topic already. So for this, I go to the exam mate. Okay, that is one website, right? I told you last time. This website. So I believe you visited this before. Exam mate. So topical. So I already select thermal property. So we go for thermal property. So paper 4. A2 is paper 4. Okay. So I select the question with the graph, with the table. You need to fill up. You come to the okay. It's a table you need to fill up. Okay. So come on, calculate. This is the table for P to Q, Q to R, R to P for the transition of this. This graph. This okay. So there is a trap. I don't know whether how many of you realize this, but I want you to get first. This is the graph. This is the 3 points P, Q, R. Okay. Okay. On top is 8. Remember, 8. The P point is Y is 8 because I scroll down a little. Top is 8. Okay. 8 to this is what? Here is 4. This is 4. 4 times 10 to the power of 5. The R is what? R is how much? You calculate and see. R is the 6th box. Okay. So 28. Just 28. Okay. So this is 8 on top times 10 to the power negative 4. Okay. So can remember numbers. 8 times 10 to the power negative 4. 2 times 10 to the power of negative. 2 times 10 to the power negative 4. Here the pressure for Q is 4 times 10 to the power negative 4 times 10 to the power 5. This 28. Okay, we go to the table. Remember the 4 points. Okay. So the gas moved from where? The gas started from P From P, the gas has been goes down Q to R, then R to P. These are the transformation happens. Okay. Okay. 2 minutes for you. Clock. Give you 5 minutes. Come on. Hope you get the correct numbers. Use first law of thermodynamics. Work is P changes in volume. And go one round, total internal energy changes in internal energy should be 0. Use that value concept. Get the numbers. Five minutes for you. Okay, roughly take down the numbers. Maybe you can take down the numbers first. I go up to the graph again. QQRRP. Yeah, I go up to the graph. Okay. Fill up the numbers. 5 numbers to fill up. All internal energy is missing. 2 work done is missing. Okay, I go up to the graph. Okay. Okay, down here pressure is 10 to the power of 5 Pascal. So remember it's 10 to the power of 5 Pascal down here. Okay, yeah. This is 10 to the power of 5 Pascal. Okay, fine. Use the graph. Calculate. Fill up the number. 5 minutes. You can discuss with your friends. Take out, you can check with your friends. Do you get the same answer? First values you always can find is the work. Okay. Then you can fill up, you can find the third value lah, in that row. The first row, you know 2 of them. The third one you can find by using the first law of thermodynamics. But there is one trap here. I don't know how many of you realize. Okay, go back to the table. I want the answer from you. I take the answer randomly. Fill up the table. I think the first thing you can work out is your work, right? You should get all the work values. Then I think you can figure out the internal energy. Yes. Okay, I believe you got a problem. What's the problem? To find the area of P to R. It's a curve. So real exam, if you get a curve, finding the area. So what do you have to do? So you have to count the number of boxes. No choice. Okay. But here, from here, I think it's difficult for you. Because it's not on the paper. Okay. So I think R to P difficult for you to find because you need a paper for you to draw and count the boxes. But I expected the other three you need to know. The top one. Get the value here, the work done here. Get the internal energy on top here. Get the internal energy for the second row. And the R to P, R to P, let me get these three values first. Okay. P to Q, work, how much you got? Anybody? P to Q, how much is the work you got? So P to Q is not zero, right? That is work done. Because which area you take, the area is to the left, right? Because V versus P. It's not P versus V. P versus P. So I don't know how many of you realize P versus P. So the area is on the y-axis. You have to find the area of the y-axis, not the x-axis. Okay. So this is the work done, right? The area work is here. Right. So P versus P. So the work done P to Q is the width times the height. Height is 6 times 10 power negative 4. The width is how much? 4 times 10 power of 5. So get the work. Anybody? How much you got? P to Q? How many Joule? Okay, go up. Two hundred 240. Got 240. So you got here 240. And this is 240 Joule, right? Got 240 Joule. Plus or minus? Compressed or expand? P to Q. P to Q going down, right? So it's compressed. So compressed means positive 240, right? Is it compressed? It's compressed. Volume 8 become 2. Compressed, so compression work is positive. Okay. Yeah. So positive 240. Okay, then, so internal energy, work out the internal energy. I think second you can find the internal energy. Third, you can find this internal energy. Fourth, you need to find the work, but because the curve difficult to work from this screen, then finally you can get these values. 5, right? This is the idea in your mind, right? Okay. So let's check what you get for your 2 and 3 first. 2 and 3. Okay, what is the 2 you got? So this is the answer you got. Negative 360, positive 720, area of the curve is 840. So you need to count the number of boxes for the 840 in a real exam. And of course, these two add up should give you the last one, negative 360. Okay. So those who got 240, the first one, 360 on top, 720, good. Those who thought of RP should be the area under the graph of the curve. Okay. And most important thing, those who realize the work is to the y-axis area. Okay. Then correct. Those who never thought the area is the work is on the y-axis, so you lose all the marks already. Okay, all going to be wrong. Okay. So what you learn from here? Check, is it P versus V or V versus P? If V versus P, the area, the work is on the y-axis. Okay. Okay, yeah, so that's about this table. This table. Now we'll be going randomly overall. Okay. So, but we focus to the thermodynamic and the internal energy first. I'm going to select that two questions. The specific capacity, heat capacity, all you learned before, so should be stabilized. So let me choose other questions randomly. Okay. Let me check. Yeah. These all are past years. Okay, one past year. So 2 marks. Try to have the answer in your mind. What do you think? State what is meant by internal energy of a gas. So 2 marks. What is that? Internal energy is the sum of kinetic and potential energy possessed by all the particle keyword due to random motion. Yeah. Sum of EK plus EP due to random motion. Don't forget the word random. 1 mark. Yeah. That's internal energy. Okay, the first law of thermodynamics, changes of U, Q plus W. State what is meant by each of the following symbol. Changes of U is what? Changes of U is changes in the internal energy, right? Q is what? Work done on the system or by the system. Q. Oh, sorry, Q is heat. Sorry. Q is what? Heat supplied to the system. Heat supplied to the system. Don't say it by. Heat supplied to the system. What is W? Work done on the system. Okay. Don't write work done on the work done by the system. No. Work done on the system. Okay. Heat supplied to the system. Work done on the system. Compression work is positive. Positive work done on the system. Okay. Some textbooks, changes of U, Q plus W, they put Q minus W. Okay. Some books they follow Q minus W. Okay, it's not wrong. For minus W, the description for internal energy they wrote slightly different. They read if they put minus W in the description what is meant by internal energy, they write like this. The changes in internal energy is the heat supplied to the system and work done by the system. Put by. You put negative W. But for our syllabus, Cambridge normally is plus W. Plus W means work done on the system. It's considered positive. Okay. So compression is positive. Okay. Expansion is negative. Okay. So one question. So there is a gas, there is a piston cylinder. The atmospheric pressure is 1 times 10 to the power of 5 Pascal. The volume change from here to here. Okay. Expansion of the gas. Okay. Calculate the work done by the gas and then show that the internal energy changes by 30 joule. You learn the technique. How do you do this? Atmospheric pressure is this. The volume change from 1.8 to 2.1. For the expansion of the gas, calculate the internal energy changes by 30 joule. So the amount of 0.18 mole or 0.18 mole of ideal gas is insulated cylinder fitted with a piston. So what is the, how do you know, rise in internal energy is 30 joule? So what is first law? Changes of U equals to Q plus W. Okay. So how to find U? You need to know the Q and W. Is there any heat supplied? They never mentioned about heat. Never said anything about heat. Okay. So we assume no heat supply, like just free uh, free expansion. Okay. So we expand it freely. No heat has been supplied. So we take Q as 0. So the changes of U is actually work done on the gas. Okay. So what is the work done on the gas? How do you find the work done? T changes in volume. So 1 times 10 to the power of 5 multiplied by the changes in volume, right? So 2.1 minus 1.8. But it's in centimeter cube. So you have to convert centimeter cube, have to convert to meter cube to find the energy. Okay. This is okay, this question. If you never get 30, you know, you can check back, right? So maybe the conversion wrong. So you should get 30. Okay. So those who thought of Q is 0 and changes of U is the work done, good. Okay. The work done is P changes in volume. And do you realize centimeter cube need to change to meter cube? There you are okay with this question. Can end up with the correct answer. Okay. We are learning the technique. Okay, next to, assuming we know the rise in internal energy is 30 joule. 30 joule rise, but which, how much of mole of gas? 0.18 mole of gas, 30 joule of internal energy rise. Determine the temperature change of the gas and state whether changes is an increase or a decrease. What is the change in the temperature of the gas? Is it an increase or decrease? How many Kelvin? How you can find the changes in temperature? You know work. You know PV, P changes to V. Yeah. Pressure is the same, right? So it's 0.18 mole of gas in RT and RT. Increase and decrease. Determine the temperature change. So any formula come to your mind? This is a little of idle gas. 2 minutes for you. Come on, figure out. The original pressure was 1 times 10 to the power of 5. Okay. The final pressure also 1 times 10 to the power of 5. It's a gas. It's idle gas. The initial volume is 1.8 times 10 to the power of 3. The final volume is 2.1 times 10 to the power of 3. They're asking what is the temperature change. The number of mole is 0.18. Any ideal gas formula comes to your mind. Find the change in temperature. Initial pressure, you know, pressure is constant. Pressure is constant. So what formula comes to your mind? The initial temperature, final temperature. Anybody? You know number of moles. You know pressure, initial pressure, final pressure. You know initial volume, final volume. You're asking for changes in temperature. Any formula comes to your mind? Anybody? This is ideal gas formula. What formula? PV equals to nRT. Can we use that? PV equals to nRT, right? Pressure times volume is equals to N times R 8.31 times T, the temperature, right? So you use initial PV, you get the initial temperature. If you use final PV, you get the final temperature. So you can find the differences, right? Okay, that's one way. Okay. Or you can use the P changes in volume, the work done. They say no sufficient data. PV is P times V can give you the final temperature. P times V can give you the initial temperature. So you can work out the changes in temperature. PV, yeah. Pressure changes. Oh yeah, correct. Check whether the change is an increase or decrease. Oh yeah, the PV equals to nRT only can be used if it's a closed system. It's a closed system. So P times okay, so you can use the P initial, V initial, nRT can get the initial temperature. Okay, so N you know, R you know, so P final, V final equals to nRT, you can get the final temperature. Okay, so the T final minus T initial can give you the changes in temperature. You can get the changes in temperature. Okay, P1, PF is actually the same. Okay. So this is the technique you're supposed to use. But it will have to be a closed system. Okay, it have to be a closed system. Okay, so I don't know why they put these 3 marks were removed. Insufficient data. See now. Okay, guys. So try to do more questions. Okay, there are lots of questions here. Go back to this Word file. Where is it? These topical questions, I put it in times. Okay, try out this question. Try to strengthen the idea. So tomorrow we'll be start with another new topic, oscillation. Okay. So remember, next Thursday I'll be giving you a test. Next week Thursday, just 30 objective questions, AS. So be prepared. Okay, thanks.